All right. So I'm Josh Mandel here with Gino and Brian on my team at Microsoft Research. We work in an organization called Health Futures, and we work on health interoperability standards. And one of the questions we've been thinking about a lot over the last year is how will large language models and AI tools impact the adoption of standards? Maybe standards won't be necessary at all in the future if the computers can all just talk to each other. But what does this mean in the near term? So one thing we like to do roughly once a year is set aside some time for a hack week. And we spent a few days this week exploring the use of large language models for structuring health forms using GPT-4 and other models from OpenAI, and looking at ways to structure the forms themselves, as well as ways to pre-populate data in these kinds of forms. So everything that we've worked on this week is available open source in a GitHub repository, which I share links to in the video descriptions. But basically, the way that we laid out our week here was trying to have fun with forms and large language models, mostly as a learning exercise for ourselves, a little bit of a team building exercise, but also to improve our intuition about where these models can help. So day one, we decided to focus on taking kind of unstructured healthcare data forms and representing them using FHIR, which has a standard for questionnaires. So we built a little application that kind of follows the flow that you see here. The goal of this application would be to take somebody who just had a text-based form, or maybe a picture or a screenshot of something that they used to give to patients or clinicians on paper to fill out, and turn that into a structured data artifact, and be able to find problems in that generation of the structured artifact, and be able to show it to the end user and help them go through some steps to iterate and improve the form. Maybe things like getting cleaner or better language so that the questions are not ambiguous. So that's what we explored on day one. Day two, we moved on to taking the kinds of results of day one, which would be the questionnaires themselves, and looking at ways to pre-populate the data in a questionnaire based on information that you could find in a health record. Essentially, we looked at techniques to comb through all the data in a health record and structure it in ways that could be slotted into the questionnaire responses. We'll talk through some of these in more detail. And then the third day, we looked at ways to fill in the user experience. So for an individual who wants to fill out a form, how do we make it as easy as possible, surfacing the suggestions that might be available from the kind of work that we did on day two. So this is all just a quick overview, but we want to dive in and show some demos and share some of what we learned along the way, starting with day one, which is all about structuring data into FHIR questionnaires. So one that I came across this week was, I thought, a good example of the kind of questionnaires that are used all over the place in medicine. There's a really long tail of stuff like this. So this was a post-concussion symptoms questionnaire, which asks questions for a patient to share what they're experiencing after a concussion. And there's all kinds of content like this in clinical medicine that hasn't been deeply standardized. Maybe it's been published in a research article, but there's often not a formal standards consensus process around.
Josh, I think your screen share is lagging.
Oh, no.
You're on Fun with Forms and LLM still.
Interesting. You know what? I see what's happening. I have to hit share this tab instead, because what I did was not to share my full screen. Thank you for the heads up there.
Yeah. No worries. Just wanted to mention before we got too far into it.
Appreciate it. So hopefully that's working better.
Yep.
And so this is an example of one of these kinds of clinical forms. It's maybe a dozen questions. Each one of them has a score from 0 through 4. And this never went through a process like standardization through an organization like Loink, where each of these questions would be assigned a standardized code that could be used for direct comparisons. So we see tons of forms like this in research and also in clinical care. Every hospital and clinic makes up a form when they want to do patient intake, and they gather data in the format that they want. So we designed this very simple web app for the first day, where we would basically copy and paste content from a form like this and paste it into our little hack week tool here. and hit a generate button to turn this into a FHIR form from free text. I'm not going to do this live because this generation call can take some time. I'll click the button, but I'm actually going to switch to my next tab where I already did this step. And on the right-hand side here, you can see a structured form that's been generated from FHIR data. And we'll also take a look at what the underlying resources look like. But you can see each of the questions has been broken out here. These are numeric type questions, so they'll accept numbers in the range specified. And then we also wanted to surface some ideas from the language model that might help somebody who is building a form like this improve it. So for example, we prompted the language model to suggest ways to reduce ambiguity or provide more inclusive language if the form itself has any language that doesn't seem inclusive or that might be ambiguous. So for example, the model here suggested that you might want to reword one of these questions to say, replace the word suffer with the word experience to avoid certain negative connotations. Now, maybe you like this idea, maybe you don't, but if you like it, you can hit the apply button and it'll make a structured edit to the data in the form. So we'll try that here. The interesting sort of experiment we were doing was with a user experience to say each of these edits can be proposed by the model in a very structured way to replace a specific piece of data at a specific path in the questionnaire. And this is using a very small language called JSON path. So that's an example of structuring some of these resources in FHIR kind of on the fly. But as you get more and more complex questionnaires with nesting and subparts, the model doesn't always spit out a valid questionnaire right away. So one of the things that we included in this process was a loop where each time the model is outputting what it thinks the questionnaire looks like, we can validate it in line. And if there's any errors or mistakes that the model has made, we can provide that feedback and give the model another chance. So for the example that I just showed here in our GitHub repository, this is the kind of JSON output that it's producing under the hood. So the model knows the FHIR data types because we included some details about all of the valid elements in FHIR right in our prompt. And it's able to use that plus the text-based questionnaire to correctly slot in things like the title of the questionnaire, dates, descriptions. It grabbed the copyright information from the bottom of the screen that we pasted in, including a journal reference here where it was first published, and then the detailed questions about each symptom that a patient might be experiencing. So between giving the model enough detail about the FHIR specification in our prompts and always validating these outputs using the FHIR validation tools, we let the model keep trying again until it produces a valid output. That works pretty well with free text fields, free text forms. We also wanted to be able to try it on images using some of the image models. But since we were building kind of a one-day demo, we took a cheap and easy approach to that, which was to take screenshots from some of these kinds of forms or assessment tools. And instead of our app accepting these screenshots directly, we can just ask ChatGPT to turn these screenshots into text. Of course, we could incorporate this functionality into our application, but this was just an easy way to try out the idea and see how well it works. So you can take the text like this, you can paste it into the tool, and then just as it did with the text that we started from, the tool is able to correctly structure this into sections dealing with different kinds of injuries that a patient may have experienced. So that's a quick view of the kinds of things that we worked on day one. And we learned a lot in this process. So one of the things that we wanted to do was just kind of share some of the challenges and frustrations that we ran into on this front. So with that, maybe let me open up for Gino and Brian to talk through some of what you encountered here.
I guess before Gino jumps into some other, the area I looked at was around how can we take larger forms and then iterate with those. And one of the issues that I found that the model would produce is that when you ask for changes to the content, is it would spit out the large chunks, but within that it'd have ... apply the same thing for the other questions. So it'd give you the gist of what it wanted, but it wasn't something you could apply directly to the JSON structure. So it took a little bit of encouraging for it to be more explicit about what it was. And then the other strategy, which was quite useful, was getting it to pass out just a fragment and specifically say what changes to the link ID. And so it would actually target, this is the whole question, to have it apply that. And that's probably really what I wanted to add to that.
Yeah, I came across the same kind of thing. I found that this happened especially for, as you say, longer prompts where you're asking the model to generate a very long output with several subparts.
Yep.
It'll often sort of do one or two subparts pretty well, and then just sort of say, you pick it up from here.
Yep.
Yeah, one of the interesting things I found in that was going through that process, it also can lose context, and part of that's just probably running past the token limit. But working with the form we posted initially in ChatGPT, as the prompts get longer, eventually it just started using, I was using prepare in this case, which is available online as well, but it started inventing questions for it, even though at the start it knew very well what was there. But as the conversation went on, it kind of forgot that we were using a particular file. So yeah, some interesting challenges when you get longer. Sure.
Yeah, I mean, this also highlights kind of one of the differences in working with the APIs for interacting with a language model versus using some of the web-based tools. I mean, I find myself using the web-based kinds of chat interfaces a lot on a daily basis. And they do work like remarkably well most of the time, but there's always this layer of mystery. Like you don't know exactly what is being sent to the model in every turn. I think there's a lot of kind of heuristics and black magic in trying to make it feel like a long conversation that just keeps going. But in practice, things are being summarized or left out in each model call. The model doesn't have the full context. So that's like one of the nice things about using the APIs directly is you get to decide what goes into the context and what doesn't. But it also introduces challenges because now suddenly summarizing the conversation correctly becomes your problem as the developer and not something the platform is taking care of for you.
Yeah, sure.
One other thing that we hit on day one was just the importance of providing good, concise, and clear instructions. So some of those are in the kinds of prompts that we wrote, explaining to GPT-4 how we wanted it to create FHIR questionnaires. And some of it was deciding like when to include some more structured data in our prompts. So like one of the things we did was to copy and paste the schema directly out of the FHIR spec that defines every data element on the questionnaire resource. And even without that, the model is pretty good at knowing what data elements exist, but it's not perfect. And to be fair, like it's kind of a hard problem. There have been different versions of FHIR over the years. We've changed the names of things and the locations and the structures a little bit. And you know, frankly, just having an easy way to remind the model of that stuff was good. So finding really concise ways to put that into the context has been really helpful. And then Brian, you also sort of experienced this on the validation messages side too. Do you want to share about that?
Yeah. So yeah, the better the validation messages that your routines are producing, because once it's produced its content, that you want to check that. And so in that iteration cycle, the better the error messages that are coming out, and also include the location in the resource on where that error is, really helps the model out. So it can know to focus in on a specific area so it can refine it. And so, yeah, between the different engines, so I used the Happy validation engine and my structure definition focused validator, which has got some much more detailed error messages. You get better results when it's got a better error message.
I will say also, like as a human user of some of these validation tools, like I also appreciate this. Sometimes the messages are very long, but also confusing. So like short and clear is really a winning formula.
Yeah. A message that's valid to a developer that has a very specific understanding of what's going on is very different to a message that you would happily show to a user that gives that context. And so the error messages that I was producing from my validator had a very clear textual portion that is expected to be shown to a user, and then a diagnostics, which has got all that extra background material and location information. So the FHIR structure for outcomes has that in it, and so leveraging that was really useful.
Yeah, this is stuff like at what line or column was the error, or at what path
Yep.
in the resource did you do something wrong?
Yep. Yep. And I guess another part of that, those requests to the API, I don't remember whether you just said it, the actually including the TypeScript definition and say produce a JSON result. That's a really good way of getting the content out rather than having to try and text parse the content that's coming in. And I found that interface, that TypeScript interface definition for the object that's coming back, including comments on those properties, becomes a part of the prompt. And so that's your little prompt to say, this is how to fill in this specific field, so I don't have to do that somewhere else. The definition itself, it did lead to having 2 copies of that, one for the code to use in TypeScript and another one in the prompt, but it's manageable.
You know, if we were using Lisp, we wouldn't have this problem. Everything would have a homoiconic representation, and the data would be the program. But yes, if you want to be able to paste your TypeScript definitions into a prompt, you do have to duplicate them. But this is like a pretty new feature in the OpenAI API surface area. I think it's one they introduced just last month, which is the ability to tell the model, don't just give me text content back, make it be JSON. They've tried a couple other ways to do similar stuff before. So they had the idea of function calls or tool calls, where the model could output a set of function calls it wanted to make in addition to message content. But honestly, it was very difficult to get the model to decide the right thing to do when it was generating text and function calls side by side. And so this new ability to request a result in the JSON format has been really very solid. And the model basically never fails to give you JSON when you apply that format. So they're definitely kind of conditioning the samples in a way that makes it quite likely to generate valid JSON. It doesn't necessarily always have all the right properties, but it's a much better start than just asking the model to embed JSON in an otherwise rich and complicated text document. So there's examples of those kinds of prompts in our repo, and it just made getting structured data out much easier.
Yeah, and I think that's an important thing just in general when we're talking about the subtle non-deterministic and hallucinations and all these different things that we want to say. You know, it can give you, if it's giving you 30 JSON responses, 28 of them might have the correct property names and the other 2 might have incorrect property names. And that goes back to the thing about the level of QA you need on all these things. And the more complicated your question, the more complicated your QA is, because obviously checking, you know, is this valid JSON, which now the model does at least that part when you ask for JSON. But getting back some of these things, especially when we were looking at extraction, that if it decided to replace a couple of the questions with other questions, if you're looking at an image, the only way to do it is to go through and look at the image and compare the actual results. And so definitely forcing these requests into very narrow scopes that are easy to test and iterate on gave a lot more success.
And then the other side of day one, you know, we were looking at generating these FHIR questionnaires. One thing that we didn't go deep on in the prototype that I showed was how to assign standardized codes for all the various questions you might ask. But this is really important. It's, you know, one of the reasons why we have standardized vocabularies in healthcare is to label these things consistently. So Gino, you did a little bit more of a deep dive on how to find the right codes given a question. Do you want to share some of what you found on that front?
Yeah, I'll share my screen here and I will clarify that to say how to attempt to find out codes. I think that's probably the best thing. And I'll say I was trying a few different techniques, and I'm going to kind of walk through some of the differences so you can see in here, just using some of the different tools that are available. I'll go to the most magical first, because magic is always fun. And using this prompt, and this is actually part of the magic, I first asked ChatGPT in a different thread how I should ask for this type of information. So it actually gave me this prompt template back, telling me that this is how you should ask for it. It was pretty close on a first attempt. It did forget that, in this case, I'm looking up LOINC codes, and it was available on the web. So the first prompt did not have that. And my requests all came back with, well, you should really get an updated version of LOINC and check that with a medical informaticist expert and all these different things. And so that, but adding that tool call essentially to tell it, hey, you can go look on the web, really does give some magical response. At the end of the day, it just came back and reasoned out what we were actually asking for in the daily step counts, came back and, you know, explained what we're looking for in LOINC, and then did come back with a fantastic and actual step count code that it's for a 24-hour period, number of steps. And it does have links back to where all that found. So that's great. I'll say same thing where I'm showing it here is it's not the fastest thing, but it does work well. And if you're okay with a lot of behind the scenes magic and sometimes getting codes that don't exist, that works pretty well. But there are a lot of other tools available. So one of them is I did a lot of work here with assistants. And the point of the assistants in the tooling here is that you can provide these files and specifically list them for retrieval and code interpreter and some of these things, and just get a little more insight into what's going on. So in this case, I'll show a couple of different examples. So the first one here is using the GPT-4 1106. And again, all these prompts are listed in the repo, but it's just saying, here's a CSV file of LOINC table core that's just downloaded from LOINC. Anyone can do for free, just go sign up for your account. And I was asking it, write some code, go through the list and give me your best responses and tell me how accurate you think you are in finding a good match. So what's nice is it does show the actual Python code it's running back and forth, but it did okay. It didn't do great, and it knows it didn't do great, which is the interesting thing, that it only found up to a 54% match, and none of these are the codes that I would really like. So it's very promising, but after several days of iterations, again, these things take longer than I would like at this point, but it didn't quite get there using the CSV file. It does, you know, when you tweak these prompts, even just a few words, it's interesting because here it's a little bit better, and it did find number of steps in unspecified time pedometer. So you could use it. It's not the best fit, but it's definitely better than I could go up one step in 7 days. That's not really useful. So it does know that it did better. And in this case, it kind of got, and what's nice here is you can see a lot more of the interactions that it's actually going through. And here it was trying, just looking for words like steps and physical activity and pedometer. And it kind of got stuck on the pedometers as the best sets. But you can see physical activity came after it. And for whatever reason, even though steps was in the original query, it did not rank that higher. But this one had both. And yeah, it's pretty confident. So it did get better, and that's kind of showing that process that you can iterate on. This next one, just for fun, I ran the best one that I had with GPT-3.5. And bless its heart, it tried. You can see it tried and tried and tried. But at the end of the day, it said, well, there aren't any to all these different terms, and then eventually found exercise tolerance. It's 100% sure that that's the best thing to do, which I think highlights, again, some of that. The newer models are definitely better at both generating and assessing themselves. And here it said, well, that's the only thing I found, so it's 100%. So definitely advise for these more advanced things using the newer models. Switching gears, instead of asking it to do code, I actually just use those tables and generated markdown files that are like a dictionary of LOINC codes. And then asked it essentially, I mean, changing the prompt a little bit, but essentially the same type of thing, saying you can only use LOINC codes in these files and tell me what you find. And so in this case, it did do better. It knows it thinks it did better. Walking, physical activity, probably suitable. I don't know that I would say it's the best match, but it's definitely better than some of the other ones we found.
And I mean, for me, the really interesting thing about this example with these uploaded markdown files is under the hood, this OpenAI system is doing some embedding-based search. It's a little bit opaque exactly how it works. I don't think they specified the details of it, but they take the files that you upload and they chunk it in some way, and they use one of their embedding models, and then they take something about your user query and embed that and look for documents that are close or snippets that are close. It would be really interesting to see exactly what content it was embedding from your user query here to get a sense of whether the problem was there or actually they chose a really good query to embed and it's just that there were too many matches in LOINC. I've seen in a lot of my explorations here, LOINC is just a very large set of codes as these things go, and they all have very similar names at the level of the text file because each one has a quantity and a type and a whole bunch of attributes that if you're not careful about how you chunk it, every row of that table sort of looks the same. There's just a few words where they differ.
Yes.
But I think this is a really promising direction, but debugging it will probably require a little bit more hands-on work with the embeddings than the out-of-the-box assistance API offers today.
Yes, and that was the path I was starting down today and didn't quite get far enough to show anything useful in the demo, but essentially taking these markdown files and creating my own embeddings and then using those to manually do all this so that you can have a little bit more control and insight. And again, I think that plays one of the common themes. The more narrow scope you can give it, the better it's going to do. So in this case, taking the LOINC codes and keeping on reducing them, I'll say the opposite of that when we did the magic one here. We were discussing earlier that, this one did the best possible thing that I could figure out myself, found the best matching code. And this has the benefit of using existing web search technology. And so not only is it using the ChatGPT AI, but it's also using search and learned history that when people are searching for LOINC patient step counts, this is the code that they're most likely to click on and be happy with and all that kind of stuff. And so same thing, you can argue that even though this is a much broader scope, what it actually did was much more focused because it could use the web search. So where were we? We were on this one. And then this last one is the same thing, just continuing to try and tweak what the prompts say and give it more reasoning and things like that. And at the end of the day, once you get kind of into one of these ruts of what it thinks is best, it takes a fairly significant change to break it up. So definitely, like in this case that we're talking about how the embeddings work and everything else, there's whatever process it decided on, it's pretty tricky to get it to change it again. So
yeah, I mean, one point to make here is underneath do they actually expose a temperature setting
no,
you adjust here?
No, they do not.
So that's fascinating. So for the chat completions playground and for the plain text completions playground, that temperature setting is kind of front and center. If you want to sample more widely, you just sort of crank up the temperature. It's really interesting. I think they're trying to come up with new abstractions, and this assistance API is an example of one there. I don't know under the hood whether the API supports a temperature setting that's just not here in the playground, or they've tried
I didn't
by excluding it.
I haven't looked at that. And I'll say for some of these things, some of this is, we'll say, promising, but has a ways to go. There were other pieces that I thought it did very well at. So explaining as we were going through some of the questions. I think I'm done here. I can stop sharing so that we have better view. But you know, as we were going through and saying, explain to me questions from this set, and maybe I stopped sharing too early, but specifically that, yeah, I'll reshare if that's all right. So in this is, we were referring back to the intake form that Josh was asking earlier, just as we were playing through it. You know, I got all these parsing done and everything else. And then I started asking it questions like, well, could you explain question 5? And then it goes through and starts telling you, you know, specifically what kinds of things that you want to rate on and et cetera. And so in this case, it's talking about sleep disturbances post-concussion. And it's, you know, in particular, I thought things like this are very useful for more detailed explanation. That it's like, oh, trouble falling asleep, staying asleep, waking up frequently. You know, yes, most, you know, many people would figure out that's what they mean by sleep disturbances, but that kind of extra exposition is pretty nice.
Yeah, I guess adding on to that is when you're back in the form design stage, actually using tools like that, or even in form entry stage. So in design, making sure there's enough information in the form for the models to be able to process that with the intelligence. So including the design extensions or the user instruction text. So it may not always be visible. But depending on the renderer, they might show it or they might have little tooltips, but it's also available for the Copilot or the AI to interact with. And so maybe it's a patient that's entering in the content and English is not their native language. They might be able to interact and have it do some form of partial translation and assistance on that. So there's a few other options you've got there.
Yeah, I mean, even just sort of translations within a language based on education level or background, it could be a huge effect. And like, actually, that concussion survey was a good example, Gino, that you pointed out. Like, disturbances in quality and duration of sleep, like that is very fancy technical language. And
yes.
You know, I think more carefully designed surveys take this into account nowadays. But frankly, it's becoming a capability that you can layer on the fly or in an automatic way now.
Yep.
All right, I'm gonna open up screen share again and talk a little bit about what we did on day 2, which was looking at ways to automatically populate information based on the data available in a health record. So maybe you've got some long questionnaire. It could be part of an intake form for a cancer registry submission. It could be a new patient visit form for an ambulatory medical practice. We see these kinds of questionnaires all over the place. And so what we explored here was just, let's start off by splitting the questionnaire into one question at a time, just to make this problem a little bit more tractable. And then the approach that we explored was, once you've decided which question you want to answer, first, let's generate kind of a search plan. We're going to assume the EHR is a whole bunch of text snippets or JSON snippets. Some of them might come from free text clinical notes. Some of them might come from structured data like FHIR API results. And in an ideal world, maybe we would just pass all of that stuff into a language model to read. But today, that's still pretty slow and expensive. So if you can focus on just the stuff that's relevant for a question, it makes the whole process here more tractable. So first thing we do is something very simple, which is just generate a sort of set of keywords to identify which snippets of the EHR are relevant. Again, we could use something like embeddings here, but the nice thing about the keywords is they're really easy to inspect and debug as a human user. You can sort of see if the model is getting the right idea or not. And once you've generated that set of keywords, you also generate on the fly a data model. And you know, GPT-4 has really good instincts about how to model data. So you give it a free text question and say, what sorts of facts would you want from the EHR? What would they all look like if you were going to take a list of facts and use those to answer the question? So it'll come up with the data model on the fly, and it'll come up with instructions for how to populate that data model. So I'll show you an example of that in a moment. And once you've done those two things, you can filter the EHR to the relevant snippets and then make a new model call to run this abstraction routine over each snippet. And at that point, you've got just an array of facts. And then you can make one more model call to say, please summarize this array of facts in order to answer a question. So that's kind of the abstract process that we're exploring here. One thing to say is as the questions get more complicated and more interesting, there's an increasing need for good sample data. So, I would love to be able to benchmark this approach against lots of other techniques for trying to do question answering. But frankly, doing that well means having a good set of EHR data that is on topic for the questions, but also distractor data that has nothing to do with the questions, because part of this task is making sure that the models can ignore the stuff that's irrelevant. Getting large sets of EHR data is tough. I've made a little bit of my own health data public, just so people can have some examples to work through or work from. But for the purpose of just this exploration, we resorted to using ChatGPT to do some synthetic data generations. So we generated some synthetic notes and then downloaded some synthetic FHIR data from the Cynthia tool and just kind of threw those together to make a simulated EHR. So this is an example of the kind of note that we simulated as a pathology report for a breast cancer patient. We've got links to the prompts that we used to generate these kinds of synthetic data as well. There's some interesting sort of techniques that you can use to get more and more representative data. If you're not careful, you'll just always get data about a patient named Jane Doe. But if you can prompt the model with even some random sorts of values to start from, you get much better generations out. But anyway, we generated a little bit of synthetic data to be able to test out some of these capabilities, and then ran that pipeline. And we built this as a command line tool rather than a web tool, frankly, because it can be pretty slow to go through all those steps. We think it might be a better fit for kind of a background job that happens before a human being is going to look at the results. So everything's been prepared and ready. And so just to give you a sense of what's happening, we run the model here. The code for this is all in the repo as well. And in this case, I asked a question right in line. And this is the question the model is going to try to answer, which is provide all details necessary to determine the patient's breast cancer stage. So the model reads that question, and the first model call generates this search term. And this is a little bit ridiculous. I could probably use some prompting to make this search term tree a little bit more streamlined. But either way, it's not hard to execute this kind of thing. It's just sort of text search with a bunch of Boolean conditions against the clinical record. And you get out that there's one matching chunk, which is the EHR breast cancer note that I showed you in the previous tab. So now we've correctly identified a subset of the EHR that we're going to use to answer this question. If there were no matching chunks, the model would just give up at this point. But since we do have some data, we keep going. And the next prompt was asking GPT-4 to come up with a data abstraction model to answer the question. So here's the model it comes up with. Of course, there's lots of different data models you could put together to represent things like TNM staging, breast cancer staging overall. But here's the model that GPT-4 came up with. It came up with a TypeScript interface representing tumor size, lymph node involvements, when was the lymph node involvement observed, how many nodes were involved, were there any metastases present, different hormone receptor statuses for the tumor, was there a result from the biopsy? If so, what was the histological interpretation? What was the grade? So the model came up with all of these little TypeScript interfaces. And then it says, great, here's the set of facts that we care about for answering the question. Any one of these specific details can count as a fact. And then in addition to creating this data model, GPT-4 also created these instructions for the data abstraction team. And the goal here is to try to describe what is in scope and what is out of scope. So deciding how to populate this data model.
A question on that, Josh. So this was all based off freeform content out of the EHR. So this was not structured data coming in. So it wasn't coded content coming in that it produced that fact model from, right?
So this fact model wasn't based on any EHR data, actually.
Oh.
This fact model was based solely on the question at the top of the screen.
And the question didn't have any actual coded content in it. It was straight textual. This is the question. So it didn't include any links or anything. Yeah.
That's right. This was all
Cool.
I asked. And there's a more detailed prompt. I won't go through it in
Yeah.
excruciating detail, but I'll just sort of show where
Yeah.
it lives in case folks are curious. It's in the source folder, and then there's a file called prompts. And the one we're talking about here is what I call the data abstraction, or here it is, create fact model for question. So the input is just that text question. And here's the prompt that we gave the model. Basically says, based on my question, I need a fact model. Here's some guidance for how to create it. Please give me a TypeScript code block and also provide instructions to the abstraction team. And this was one of the most impressive things for me. So I asked it to provide instructions to determine when to create facts and when to discard irrelevant data. And it did really well with this across the board. So in this case, in terms of discarding data, it gave these instructions. If the data doesn't clearly relate to one of the interfaces or is not related to breast cancer staging, it should not be abstracted. And that sounds kind of obvious, but when you're making the data model, when you're making the API call to do data abstraction, you might be giving it irrelevant data. You're not really sure at that point. So having this kind of instruction in place is very, very helpful. When in doubt, seek clarification from a supervisor. Maybe that one's not as helpful. But overall, these instructions are really quite good, and the data model is quite decent. So what happens when you now make a model call passing in the note and passing in this data model and instructions is you get an array of facts out. And so the array of facts looks something like this: a bunch of dates and hormone receptor statuses, lymph node involvement that are consistent with the note. And then the one last model call we make is, here's a list of facts, please answer the question. And we get out this kind of structured view, in this case, of the data related to the patient's breast cancer stage. So it inferred something about kind of the questionnaire structure here, which it knows about, and created a structured set of results from those facts, hinting at the tumor size, lymph node involvement, and so on in kind of this FHIR format. So all of this was pretty slow to run and pretty highly variable across executions. So I wouldn't say this is like a solved problem by any means, but I was really impressed in particular with GPT-4's ability to generate these data models on the fly. And then once that data model was there to kind of scaffold the results, the abstraction logic worked much better. It had a very concrete and specific target to work from. So for me, this was pretty compelling early experiment. But the real question is, how reliable is this technique overall against real data or against realistic data? I think we need much better data sets for us to start building benchmarks on. Right now, these models are competing on how well they can answer USMLE questions or medical licensing questions, which is really important. But the models are now kind of maxing out performance on those kinds of benchmarks. I think it's starting to be time where we need very clear, clinically relevant benchmarks, like this kind of data abstraction task. So I'd love to see or figure out how we can build more data sets around these kinds of tasks.
Sure. I thought that was interesting in the variability too, because one's axes of the variability is obviously what it's picking for facts and everything along those lines. But one I didn't expect was the variation in the tone of instructions. And so we definitely noticed that some runs, for whatever reason, were very much like, oh, you can do this, let's get this data and change the world. And other runs had instructions that were more, do as you're told, this is your job, make sure it's right. And so again, it would be interesting to be able to see into what was causing those differences, because the prompts didn't have differences that should have accounted for that. And so it's pretty interesting to try and guess.
Yeah, and I sampled all these with a temperature that was either 0.7 or 1 at different times of the little experiment here. So like the variability I get, but I would love to know if it matters. Like is one of those tones actually more effective at causing the abstraction to work better? I'd love to have a data set to answer that kind of question.
Yep. Sure.
And the other area I'm super excited about seeing, and I'll guess we'll talk about that more in the UX side for our day 3 session, but really how this, even though this is on unstructured content to a large extent, when we've got structured content, it can still work in the same sort of space, because I played with the IPS as the data source for my experimentation with it. And a part of the stats that I was getting it to produce out was what confidence does it have in the answer, and where is the source of that information. So it was sort of combining what Gino and Josh, what you'd both put into your stuff through from day one, was how close is this of an answer, and where did I get it so I can check it later on. And the other thing that really gets me excited about that is it can end up being the information to help guide the production of the real via structured data capture, or SDC, extensions for pre-population. So it can go from the expensive GPT style interaction and through refinement, get it down to say, well, actually, we know how this works, we know what it is, and guide it to actually produce reproducible content with SDC. And so it becomes a way of shaping it, but don't have to go in understanding what it was that you wanted in the first place.
Yeah, that's the magic of like what sometimes is called program synthesis. So like rather than asking the model to give an answer, you ask the model to write a program that can be used as many times as you want.
Yeah.
And you reminded me, Brian, there was one more demo I was going to show from day 2. Everything I showed initially was about unstructured data, looking at free text notes. But I did want to show one example just from my own medical records using FHIR JSON data. So this is a very simple one, but just a data analysis task. I uploaded a zip file with all of my FHIR JSON data in it from my local healthcare provider here in Madison. And I said, play the role of a digital assistant. Here's an explanation of what's inside this file. Here's some instructions that basically tell you, look at the data first before you try to write a program, and then write a program. And then I just asked it to create a table of blood pressures over the last 5 years. And you can see it successfully does that. What is pretty remarkable to me is that, initially it unzips the file and looks at some of the JSON, and then it just proceeds to write this function, which is not the most robust blood pressure parsing function, but since it had a feedback loop when it was writing this, it was able to correct errors. And ultimately it, figures out how to look through all the resources, make sure they're observations, drill into the different components of those resources, and pull out just the systolic and diastolic components and the dates. So it really did a pretty good job of synthesizing a program like that on the fly. And that kind of thing makes me think that analysis might be increasingly common and capable over time. All right, so that was day 1 themes, day 2 themes. Brian, do you want to take us home with day 3 around pre-population and the UX?
Sure. Let me see if I can get my mouse under control and share the correct screen. Excellent. So basically back to our Hack Week demo. Each day I come up with a new image, which was using DALL-E, which was the 3 of us, which was kind of fun. Anyway, so with our pre-population, so I was using, so this is the CSIRO renderer on the right, and our actual answers on the left. And so what we did is we had a capacity to click in. So we did some mods to the renderer to detect when is that focus change going in. And so you can see now I got the focuses on that full name. And so it's pulled that detail out, which is kind of cool. And if I go down to the IPS bundle and look for patient, we go. Should be able to find the patient in here, patient summary document. See his name. That's Britannical. So that's who it is. So Brittany, Britannical, BR, Sarasota. So we can see it pulled that out. We can click into the next field and we can see it go and pulled that information out. So that's kind of a really rude interface where it's actually just clicking in. So it was really an experiment to try out how does it feel if it just goes and does it for me without doing stuff. And so with our normal SDC pre-pop, you normally come into the form and it's gone and done all that as you're going. And so it sort of felt really strange doing it this way. And I can see it's now actually pulling these values in correctly. This is using the GPT-3.5, so it's a bit quicker. Now, if you notice what it did there, it had BR and now it's got NA. So it took multiple stabs at actually pre-populating that. Now, this is a terrible experience and I would not recommend this approach. But I think it was well worth the experiment to see what that felt like to use. And if I look at the actual content that's coming out, so look for, here's our possible answers to name. So it's looking for a suggestion for name. And if we go in there, we can see that in there it says, well, this is the answer text, which is what we put in there. Britannical, it's sort of squashed in, but that's what it suggested. It goes, I'm 100% sure this is right. Interestingly, I didn't give it a range, 0 to 1 or something like that. And this is actually the first time I've seen it say 100. Normally it's 0.9 or 1, so maybe there's some guidance. But also gives this label is the description of why it selected this specific text. And I don't know why it's sort of crushing that down there, makes it difficult to actually see. I'll just open it up a bit further. You can see that it found the full name, was including the family name and given name, and it said it came from the patient resource. So yeah, that makes sense. And we'll see, was there any difference in the other? So it's repeated it multiple times, and we've got that capacity going through. And what did it do with the family name? So these are all kind of useful. So yeah, okay, it's still doing its 100% thing. It says where it came from and the patient resource name attribute. So maybe I should be specifying to say, how should you describe the source? But if it's not going to be a FHIR resource, then maybe that is appropriate. So it could say which part of the document. And it's still sure, family, given, middle name. So what did it suggest with middle name? So that'll be interesting. So it said, yeah, the middle name Burr is derived from the name, where it's listed as part of the name. And yeah, so that is correct. So that's fine. But there's that confidence of 0.9. And it said, yes, I did create that and put that in. So that was fine. And then we had another crack at it, or the app. And what is it given for reasoning? Since no middle names are provided in the data, it's safe to assume that they don't have a middle name. And it checked that. And so, funnily enough, it actually thinks that's more accurate, but it's even wrong. So yeah, so this is the GPT-3.5. And the interesting last one, so I'll just click into the title field because it gives me patient summary. How cool is that? Yeah, not exactly an accurate answer, but it's an
the
answer.
title of something.
It is. And if we look in the answers, we can see that it comes up with, it's 100% sure, or 100 confidence, whatever that is, that the summary document is that. And so that's really a good example of that is a valid title, but the specific query, I wonder if I've actually got the network on. Yep, so let's look at completions. So the query it was actually asked is, it's not actually even showing now. Yeah, saying the patient is trying to enter a response to the following question title. So it doesn't have enough information in that context to know that you're talking about the patient's name's title. So this is a case where some further refinement on the prompting to give there to say that this is actually the title in the patient details and the patient name, because that's the context in the other questions that would give a better response. Yeah, so that was sort of where that was at showing. And
if I can jump in too, I just think the middle name is a pretty interesting highlight of the pedantry of the system, which is to say in FHIR, if people aren't familiar, there isn't actually a field for middle names. So to get a middle name, you have to look at the given name, and then you assume that the first one is the given name, and additional ones here we're labeling as middle names. So when you look in the spec, if you go way into the details, you can see that it does have an alternate name, a first name or middle name on that field. But it's a pretty specific thing, niche thing to actually go and find. And so these are the kinds of things like, well, in that specific prompt, you could go and say it's, additional given names should be labeled as middle names and different things like that. But seeing how it changes that confidence, you can see it's like, oh, it thought maybe it's, additional given names are the middle names. Then it's like, wait, it's not labeled as a middle name, so I can't use it. So it's a pretty interesting insight into how it's working there.
Yeah. So so that was a good thing. So how would a UI be better represented? So if I look at some other experiments that I've done previously, so this is the same sort of thing where we've got that form definition. So is this the same? This is the same form definition. So if I look at that render, that's the same form. And so I can choose to validate. So once again, with the quality of the validation logic that happens. This is what happens when we do things live. It wakes things up. And so we get some error messages to saying that, oh, this is some errors. I happen to pull that into some different areas and say, okay, well, what about this one? So I can click on that. And a better example is to say, okay, so an AI chat to help you with that issue. So it actually pulls the error message that it found here into the expression and says, how can you help me with this? So it's got that broken down content and say, yep, all right, help me with that. What can you do? And then so when it comes back with that response, rather than just going jam straight back into the field, which is exactly what was going on here, to put that in, actually come back and live demos and actually tell you this is how you should resolve, this is why, this is what's wrong with the error. And yep, there we go. And so it's explaining what is the problem. You've got multiple. It says you should be including this first section, which is the correct fix for that. Because you can get multiple medications, so therefore the status would be the first one, and then have a way of applying that change back into the expression. And then that's what the completed item would look like with that fix in place, and that's what you would apply back. And you know there it's got little types, so it knows how to apply that content back into the source content. And just rather than being tabs like this, you're better off having it as a little pilot to sit beside to say, here's our expression. What's wrong with that? How can I help with that? Well, we don't want to use the trace, so remove the trace. What's going on there? And says, oh, that's cool, so we can remove that. And so that's the sort of user experience that you want to actually get, so it's helping you as it goes on. Yeah, so I think that was what I wanted to share there.
Just one question on the, you don't have to show the screen, but just on the interaction that you built in with the International Patient Summary, that IPS document. You were calling GPT 3.5. Were you passing in the whole IPS document?
The whole IPS document, yep.
Cool. So, it actually, for GPT 3.5, this was a significant challenge to look through that whole document and try to answer kind of one narrow question.
Yeah.
I don't know quite how long it is, but those documents can get pretty big.
Yeah. The other thing, and so with that specific one, so why I was focusing on that, even though it was a super simple patient name details with a large context document, the subtleties between those different fields with title and name and preferred name, and where could that come from the source document? Did it come from the practitioner's name? Did it come from a contacts? Did it pull the right title out? So that those sort of subtleties. So that was really where I was trying to drill at the edge.
Yeah, I mean, when it comes to providing kind of the clearest instructions that you can, of course, sort of the section of the form that you're in matters a lot. So being able to say this patient details, sure.
Yeah.
It might also be really helpful to just share information about some of the adjacent questions, like, you've already answered these three, so it's
Yep.
different from those. We're getting
Yep.
at, what is unique about this one we're asking you now?
Yeah, yeah. I did try that. So when I was passing through not just that one, I said, as part of that context, I don't even know if it's actually in that one. It wasn't showing very well. But to say that these are the other questions within that specific item.
Yeah.
And it was getting mixed results. So I think that's an area that could do with some more refinement, and possibly some just more interactions straight with the AI itself, to self-reflect to make sure that it's not answering from some other thing.
Awesome. Well, so this kind of covers our explorations over the course of the week. I want to say thank you to both of you guys. We covered a lot of ground, and obviously we just scratched the surface on many of these capabilities. But I learned a lot. I have a lot of experiments I'd still like to run, based on the last couple of days. And more than anything, I'm feeling convinced that we need good data sets or paths to have open data sets. And I honestly think that sometimes open might trump other kinds of quality, makes things easier to explore and experiment with, not to the exclusion of other data sets, but just things that are no friction.
Yep.
For sure. That does, it was interesting. We were having a little bit of discussion about this earlier, and on the data sets, it does introduce the contamination problem, which can be interesting for saying that if the request we're asking, and that I was trying to be careful that I was using the same request on daily step counts and things like that, because if you happen to have something that has a little more traction or a little less traction on the internet, then you get very skewed results. And so I think that'll be interesting as we do open up these data sets. I think all of the AI companies will happily train on those data sets, and then we're going to have to reevaluate all of our answers based on that at some point. So,
well, that's one of the nice things about synthetic data sets, I suppose, is if you create a synthetic benchmark, you can always just make more.
There you go.
Yep.
Perfect.
Awesome.
Yeah.
All right, guys. Well, let's sign off. This has been a lot of fun, and we'll see you next time.
Thank you very much.
Definitely. Thank you.